chain rule is a pretty powerful rule because I think it leads to a skill set that will make you a far more powerful mathematician. Basically, we use it when we think that what we're dealing with is too difficult to derive by itself, usually when you've got a function inside a function. So you could have sine of 4x squared plus 7, say, or you could have something to the power of something. Okay, and we've got an example over there. It relies very heavily on substitution. Substitution is a great tool because you can manipulate equations essentially to do what you want when you use substitution effectively. So over here I've got an example. Okay, I think it's probably the easiest way to run through it. And I've got an example of 4x squared plus 6 to the power of 3. Right now, the way that you would probably go about doing that is expanding that 3 times, collecting, writing that down as 4x squared plus 6 multiplied by itself 3 times, and then expanding. Very, very long-winded way of doing it. Instead, what I'm going to get you to do is say, well, let's let this thing here equal u. So now we've got y equals u to the power of 3, where u equals 4x squared plus 6. I don't need the brackets. I've just put them up to show you what part of the equation. Step 2 is to find du dx. So we can find the derivative of that because this has now replaced y. So du dx is the derivative of u with respect to x, which again we can find very simply 8x. Happy with that? Second step is, well, y equals u to the power of 3. Now find dy du, which is, again, you're just replacing your x with a u. You've got 3u squared. And this is the part where the chain will sort of vary through substitution. So now we use the fact that we know dy dx is what we're looking for. And that equals dy du times du dx. Put that in my pocket. I bet the audio quality can be really good. Dy dx can be found by cancelling those two. Happy with that? So we're essentially breaking our problem into 2 parts. So we've got dy du, which is 3u squared times 8x. What do I need to do now? So, dy dx equals 3, 4x squared plus 6 times 8x, which gives us 24x, 4x squared plus 6. What? Oh, u squared, correct. Yeah, u squared. Happy with that? A lot easier than writing this out 3 times. Here, wherever that is, writing that out 3 times, multiplying it, crab clawing again.
How can you put the square on?
The squared, because it was u squared up there. So I just literally sub whatever u was back into the equation. And I've collected like terms with my 8x and my 3.
Yeah.
And then if I needed to say what was the value of x at 5, I just said x equals 5, put that in my calculator. So it's almost not, it's not a rule, really. It's not, you're not learning anything different. You're substituting and dealing with fractions. It's a really powerful thing to be able to do that. Okay, we're going to learn the quotient rule and the product rule next. You will need to remember. But this one's very powerful, very easy to remember if you've got good processes. Sweet.